Alright, greetings, travelers. Let's see if everything's working. Can everybody hear me? Can everybody see me? Well, not me, the stream at least. And more importantly, can you hear the music in the background, which is a thing that apparently you have to actually make a source channel for the music. I never knew that, so in the last, I don't know, 12, 13 months that I've been off and on streaming, I've always had music on and I hear it in my headset, and sometimes it's really loud and I just kind of deal with it because I'm like, I gotta turn it up so that everybody can hear it. No one could hear it. No one in the stream could hear it. It's okay. This is a learning process. Greetings to you all. I see people on different places. I see a couple on Facebook. I see a couple over on YouTube, and a couple on Twitch. This is why we multi-stream. We're all over the place. Wherever you are, I hope you are having a wonderful day. You're probably wondering what in the world you're looking at. Well, this is our virtual planetarium, which is technically out of this world. We are going to be using this software. This is Stellarium. You can download it for free. Stellarium.org. I am not affiliated with them. I just like using their software because it's useful for teaching and for studying. Actually, they even have some built-in controls. If you have a telescope that's electronic, you can actually control it from your Stellarium software in some cases. So that's pretty cool. We'll be going over a couple of different things here. Again, if you're new to the channel, like and subscribe. Click the little bell so you don't miss anything. We do try to do this every Monday and Wednesday and Friday, but the last few weeks have not been kind, and so we're trying to get back into the swing of things. We usually start out our show with kind of current events, talking about what's in the sky or what's happening right now, particularly with the Mars rover known as Perseverance, because that is, of course, the NASA mission that just landed on Mars a couple weeks ago. Actually started moving around. They drove it a little bit. So we'll look at some pictures there. We're gonna look at that thing's on the wrong screen. That would help. That is also the wrong screen. We'll be using this a little bit later. This is our other virtual planetarium. This is Universe Sandbox, or is it Sandbox Universe? I can never remember the name. It is Universe Sandbox. I just have it labeled wrong. We'll be using that to kind of look at the Earth and the Moon system, look at our solar system as you see here, and use it to compare stars. We'll be talking about stars a little bit later on in the show. We also have a web browser. There's what I was looking for. We always start out by talking about the astronomy picture of the day, which I missed my highlight. There we go, astronomy picture of the day. You can find this by typing in astronomy picture of the day into your favorite web browser, and you'll get something that looks like this, like it's from the old times, the ancient times, Web 1.0. And it kind of is. It's actually from 1995. If you click on the full archive up here, you will get the archive going back to the year 1995, where the pictures are very, very small and not all that good. They've gotten better over the years, of course. There are some browsers that have issues with the archive for some reason, prefetching. I don't know. I don't compute that way, so I do apologize, but do take a look at it. Every day they do put up something different, and I'm just going to kind of click around, and you are able to actually get it. Oh, this is a great picture. I'll talk about this in a second. It'll give you a picture. Sometimes it's a video, but it'll be a picture with a description down here in the bottom with explanations, and then links. If you don't know what they are, you can just click on it and go down the rabbit hole that is learning about astronomy. What this is from just the other day, this is from March 4th, my friend's birthday. Happy birthday, Jude. This is actually something we'll be talking about a little bit later. This is a picture of the planet Mars. That's this large red orb down here. The Pleiades, the Seven Sisters, Subaru, this beautiful little star cluster right here, this blue star cluster, very young, hot, bright blue stars. And then just off to the left here, you see a bright V of stars. Those are the Hyades. Those are the stars that make up the face of a constellation called Taurus, the bull. And you'll see a nice bright red star right here. Now this is actually Aldebaran. It's a red giant. It is the eye of the bull. Unfortunately, these do look the same in this picture. That's probably the way they were processed, but in reality, when you look at them in the sky, this right here, this is Mars, will not twinkle. Stars twinkle. Planets don't twinkle. Twinkle, twinkle, little stars, not just a song. It's actually true to the way the science works. So, yeah, we'll talk about this in a little bit. And also look at all this dust and gas. Hydrogen alpha region up here, this bright red cloud up here. Ah, man, all these little points of light you see are other stars. Some stars have planets around them. Some stars have other stars around them. There's just so much to talk about. We're going to try to get to some of these things in just a little bit. But yeah, this is Astronomy Picture Day. This is why I love starting out with it, because you never know what you're going to get. Every day they give you something new. This is actually what I kind of mentioned a little bit ago. This was Perseverance taking her first drive on the planet Mars. Look at them tracks. Even ran over a rock, and the wheel didn't break, so we know that's good. I started here, and I've moved to here, and I did a circle. Hopefully they don't do anything weird like draw gentleman sausages or other terrible things. You could hypothetically draw stuff on Mars by driving the rover around in certain patterns, but yeah, interesting rocks. Lots of flat rocks, it looks like, in this particular region, and then this weird, what looks almost like a volcanic rock right there. You see the little bubbles. Can we zoom in? We can slightly see these little bubbles right here. That rock had a lot of heat in it at some point. Very, very cool. Again, good to see you. I see the numbers going up on various sites. Good to see you. Thanks for joining us. Please share, like, subscribe, all the good stuff that you do for streamers. If you're new to the channel, again, like, subscribe. Please tell your friends. We try to do this every Monday, Wednesday, Friday. This is just incredible. This is in the Eagle Nebula. These are known as the Pillars of Creation. Now, these have hypothetically been destroyed already. A couple years ago, or a couple decades ago now, Hubble took a picture of an area of space called the Eagle Nebula, and it had these pillars inside of it. Again, this is gas being blown away, and actually probably a star. Looks like this star is flying right through it. This is the way astronomy truly looks when you process pictures. You actually have to take many, many, many pictures and layer them over each other, and then subtract away the gunk and leave behind what in essence is an HDR photo. That's why the stars usually have this very, very interesting diffraction pattern going on in them. That's actually another key when you look at pictures from space observatories. You pop in whenever you can, whenever you want. It is not a big deal. Please stop me whenever you feel like it. Ask questions as we go along. When you look at pictures like this, things to look for. If you see bright points of light with little streaks, you see all these little streaks pointing at them, those are going to be stars. There are some photos you will look of deep space, and you will not see stars. You'll actually be looking at galaxies. There'll be like 1 or 2 stars, and the rest will be galaxies. I'll see if I can find something like that here in just a second. This is actually today's astronomy picture of the day, and it's of the comet Neowise, which we saw last year. And those of you that may have been around, or maybe were, talking to me or keeping track of social media, I tried to take a good picture of this comet, to go out and see this comet, and literally, and I live in a desert, it never rains here. Every time I went out to see this comet, there were clouds or rain, and the one time that it actually cleared up just enough for me to see it, I was out in the Jemez Wilderness in New Mexico, and my camera was completely set up wrong, and I got nothing. I had used it for something else, and I completely forgot to reset it for doing astronomy photos, and all the settings are wrong, and I just I was very upset. It was a sad time. Now, this is what's interesting about this photo. Obviously, I did not take it. This is someone named Nicolas Lefondu. My apologies. Nonetheless, they, not sure. They took a very wonderful photo of this. When you look at a comet, you're looking at a ball of ice. Maybe some rock inside of it, mostly ice. And it's out at the edges of our solar system. And we'll look at that a little bit later. As it gets closer to the sun, it'll heat up. And it'll start giving off gas. It starts sublimating the gas. The ice turns directly into gas. And any of the rock particles will take off. They'll travel in one direction. So this tail right here, this is going to be a kind of a dust tail, and then you're going to have an ion gas tail. So the actual ice is just turning into gas. That's this blue tail. But Neowise had a third tail, this bright red right here, and it was kind of confusing. It's actually really pretty to see. But the question is, why? Why is there another tail? Well, as it turns out, Neowise was kind of special. Come on, scroll down. There we go. Let's see here. In fact, that's the question here. What created the unusual red tail in Comet Neowise? And just a single one-word answer. Sodium. 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 You know, sodium chloride is salt, table salt, but sodium itself is just a standard element, and there was some sodium, it seems, in this particular comet, and as it sublimated, some of that sodium started giving off a glow, giving off a light. Sodium comet tails have been seen before, but are rare. That means Neowise was really, really rare. That makes me even more frustrated. So I hope you saw it when it was available, when it was up in the sky. I sure as heck only got to see it briefly, and only once. Comets are rare, they don't always show up in the sky, so when they do show up, do go out and see them. I was lucky enough to see Comet Halley long ago in the 80s, you know, back in the prehistoric ages. And I was also lucky enough to see Comet Hale-Bopp in the mid-90s, and Hale-Bopp was just incredible. If you can imagine a comet tail taking up half the sky when you look up, at its brightest point, I mean, Hale-Bopp was just enormous. And you could see something like this just walking out into your front yard or out on your porch or balcony or wherever you happen to live. You just look up and you could see it. Even in the cities, you could see Hale-Bopp. It's really, really pretty. But again, very, very rare. So there's a quick look at that. Let's see, we kind of talked a little bit about Perseverance already. If you haven't found Perseverance's website, just look it up, Mars Perseverance. They are putting up photos, and actually this is kind of a GIF file of a couple of photos all kind of put together. You'll notice it says Sol 13. They don't measure the mission in days, they measure it in sols. A sol is a Martian day. Day on Mars is actually 24 hours and 37 minutes long. So the schedule for the people that run this rover over the next weeks and months will be constantly changing. Imagine going into work today at 8 o'clock in the morning, and then tomorrow having to be there at 7:30. Or actually, no, you have to be there at 7:20, I guess. And then the day before that, 40 minutes earlier, and the day before that, 40 minutes earlier. So all of a sudden, instead of going into work at 8 in the morning, you're now going to work at 3 a.m. And then 2 a.m. and then 1 a.m. And you'll be doing that for the next 2 to 5 years, if not longer. That's what it's like to be on the Mars Perseverance staff and crew, which, frankly, sounds amazing. They're on the cutting edge of science. Science! Speaking of which, we should probably get into the actual show. Again, feel free to stop me. We're going to talk about the sky, which is represented here by this blue circle we see here. And we've got no horizon. We've got it blocked off and turned into this green. If there were no sun, you would, of course, see stars. Or, more importantly, if there were no atmosphere, I should say, you would actually see the stars during the daytime. This is what the sky looks like right now during the daytime, with no atmosphere diffracting sunlight, but we do have this beautiful atmosphere that we do breathe in, at least when we're not poisoning it with terrible, terrible gases. It looks like this. This is, of course, our star. Excuse me, our star, the sun. Please do not stare at the sun. Do not do what I'm doing now. I'm zooming in on the sun in a virtual planetarium. Don't do that in real life. Unless you have proper filters, you can and will damage your eyes. You will mess up your telescope. You'll mess up your camera. You'll forget to turn off your cell phone so you get Zelda sounds during your stream. You know. Good stuff. Please make sure you have a snack or a drink. Today, instead of drinking green tea, we're just drinking cold water and snacking on some peanuts. So, hope you have something tasty to eat and some burning questions. Maybe you have them, maybe you don't. That's all right. We are looking at the sun. If you do have a filter, you can look at the sun and maybe get lucky and see something like this. We'll look at the sun up close in a different software package in just a little bit. But sometimes the sun gets these little things called sunspots. Now, they rarely get this high up on the sun, so I don't know why they put them like that in this image. Most of the time when you see sunspots, they're going to be within 35 degrees, 40 degrees of the equator, so kind of along in the middle here. But a sunspot is an area of the sun that is highly magnetic and very, very cold. So the surface temperature of the sun, about 6,000 degrees Kelvin, give or take. And a sunspot's only going to be 3,000 or 4,000 degrees. That's a lot colder, so it starts to get dimmer. And around these things are where you start to get these little things that are called solar flares, and you'll also get stuff called coronal mass ejections. I guess I should mention that. I believe there was actually a coronal mass ejection the other day. That's not what I was looking for. My apologies, I have to bring up a different window. Come on, baby. Nope, not that one. Yep, nope, not that one either. Come on, Sweet Pea, you can do this. What kind of filters do you recommend for viewing the sun? Well, primarily you want to get what's called a hydrogen alpha filter. You will see the sun in a reddish color. If you have a set of binoculars or a small telescope, they often make these aperture filters that will cover up a portion of the front of your device so that you can see the sun without damaging your eyes. I'm not sure why I can't get this thing to switch over. But yeah, hydrogen alpha and then just a solar aperture filter. They usually have kind of a silvery tinge to them, so they reflect a lot of sunlight back, and they let through just a little tiny bit of sunlight so that you can actually see the sun without damaging your eyeballs. Okay, so now things are finally responding. There we go. There's one. There's two. I'm not sure why I can't get it up. Anyway, there's a thing called the Solar and Heliospheric Observatory. And the SOHO is what it's called. It actually is an observer looking at the sun. Can I just close this? Is that what I need to do? Fine. This is what happens when you do live stuff. Please bear with me. Anyway, SOHO is the Solar and Heliospheric Observatory. It does look at the sun all the time. And it is actually in space. And wow, this is really weird. That program's not even open anymore. One moment. Yay! There we go. That's not what I want you to see, but there we go. All right. Something got stuck in the queue there. All right, so here we are. This is the Solar and Heliospheric Observatory. This is actually where you can safely view the sun every day or night, because this thing's actually closer to the sun than we are, and you can see the sun. So here's a sunspot off right now. This is actually the sun right now, the way it is outside. March 8th, that's today. So you can see this anytime you want. They've got lots of different filters, so if you can't afford to buy your own filter, or you just want to see what the sun looks like through different things, different filters, feel free to come here. This is a observatory that looks at the sun in ultraviolet and in infrared, and actually lots of high energy. This is looking at magnetograms, so everywhere you see these darker splotches, one side's positive, one side's negative. And you're going to see sunspots are going to be in these regions. There we go. So that bright sunspot, or that dark sunspot we saw there, looks kind of bright in this picture. That's right there. So let's you kind of compare what's going on. So let's see. This is regular visible light. You see there's a sunspot way over here. The exact same spot in the magnetic thing that we just saw a couple seconds ago. There is something going on here. Maybe it's going to become a sunspot very soon. But let's look at it in ultraviolet. Look at that. There's that sunspot right there. There's that other magnetic disturbance. See the things right here. So again, this lets you see lots of different portions of the sun. The sun is incredible to study. There's also what's called the LASCO cameras. I don't remember what the acronym means, but what they do is they put a circle to cover up the sun. So the sun is represented by this white circle here. The dark circle is actually what's blocking out all the extra light, the actual corona of the sun. And what we see here is actually material being blown out into space. What we call coronal mass ejections. That one's actually the zoomed in one. The blue one's always further out. And what's cool is that's the planet Venus. That bright splotch right there, that's actually the planet Venus. Sometimes in these SOHO images, you will actually see comets that you can't see in the nighttime from our point of view. You'll see comets, and sometimes they'll fly by and then they'll fly away. Or other times you'll see them curve and they go right in the sun and they never come back out because they're dead. They're dead. Dead! Dead, I say! They get burned up. Anyway, this is called the Solar and Heliospheric Observatory, SOHO. They do have a whole thing on space weather, talking about solar wind, all the material being blown off the sun, lots of magnetic stuff. They actually have a thing on the northern and southern lights here on the Earth, which are caused by material coming out of the sun. That's actually how it all works. Material from the sun hitting our magnetic field around our planet, hits our northern and southern poles primarily, and that causes excitement in the atmosphere, and that gives off the glow. That's the aurora borealis. The northern lights and the southern lights, and that's all caused again by the sun. SOHO's been up there for 25 years and counting. I've been looking at SOHO for years and years and years. That's amazing. Nonetheless, that's just a kind of an aside. I do need to reboot the software because for some reason the streaming software decided to just get locked onto one thing, and it just stayed there forever. I don't know why it did that, so I apologize for that. Let's see if we can get Stellarium back up. That is not Stellarium. And yes, sunspot is huge. Yeah, so sunspots, they tend to be Earth-sized or bigger. So whenever you look at a picture of the sun and you see a sunspot, that's Earth-sized. When they get to be really big, they can be up to Jupiter-sized, which is about 10, 11 times bigger than the Earth. They're huge. The sun itself is just gigantic. And it's sitting right now in the southern part of the sky. If you walk outside, hopefully it's a nice weather day for you. Here it feels like spring. We're going to speed up time. I do not recommend that in real life. Do not speed up time, because life is too short as it is. Tasty. Now, we're going to go ahead and let the sun set. And we're going to look at the nighttime sky. We're going to find a couple of constellations. We're going to learn how to find the North Star, because that's always helpful. I do that in almost every single show, unless someone says they don't want to learn about that, and in which case I won't. But no one ever says that, so that's okay. Now, we're going to stop right here real fast. We'll notice that we're setting the sun in the western part of the sky. That's the way it always is. The sun rises in the east and it sets in the west. During the daytime, the blue light you see in the sky, the blue hue in the sky, is caused by the way light diffracts through our atmosphere. It gives off that blue glow, and during the early morning, or in the early evening, the longer wavelengths of light. So look at the rainbow: red, orange, yellow, green, blue, indigo, and violet. Roy G. Biv. Blue light, short wavelengths, scattered around during the day. Opposite side of the spectrum, the red colors, red and orange and yellows, those get through during the afternoons and the early mornings, right along the horizon, so we get the beautiful sunrise and sunsets that we are used to. There we go. The stars are out. Look at that. Let's leave it like that. Now, this is kind of an idealized version of tonight's sky. We're looking south-southwest. You notice we have kind of cardinal directions labeled on the dome. You obviously don't have that in real life. If you do have a cell phone, a lot of people do. If you have a cell phone or a tablet, you can usually download something like Google Sky, or I think Apple has a Sky program as well. I think there's even a mobile Stellarium version, but I'm not sure on that. You'll have to check on your own. But there's lots of different sky softwares you can put on your phone to help you kind of find your way around. It kind of lets you cheat a little bit, but what's better is to be able to find your way around the sky without using those programs. The problem is, it depends on your sky. And what do I mean by that? Well, in our planetarium here, we have it set to a very low light pollution setting. Light pollution is the artificial light of, well, our cities. And if you live in a very light polluted area, it might look something more like this. Not too many stars. If you're in a big city, Tokyo, New York, I don't know, Dallas, Miami, places where there's lots of light, you're not going to see as many stars. And unfortunately, that means that we're all kind of divorced from the beauty of the night sky. Every culture on this planet has some sort of sky story. Stories. They look at the sky and they come up with shapes. We're talking going all the way back to the time of the Babylonians, and even further back, Sumer in Mesopotamia, back at the cradle of civilization, as it was called, between the Tigris and the Euphrates River. I only see planets and the moon if in the city. Yep, that's the problem with being in the city. It's okay. Sometimes we gotta live there, but it's always good to get away, take a look at the sky, and reconnect with the universe itself. Hey, if you ever come visit out here, we can go out and see the sky. Lots of dark sky areas out here in New Mexico, because it's kind of a... former person I used to work with said that this place looks like a desolate moonscape, and in some respects, I guess I understand that, but at the same time, that's what makes it pretty. Undeveloped, pure nature is very, very cool. Now, where was I going with this? Ah, yes. Sumer. Going back to Sumer, they had a story called Gilgamesh, right? That's like considered to be the first epic poem and story, and a constellation that we call Orion today was apparently long ago referred to as Gilgamesh in the sky. Or maybe you've heard of Osiris. Osiris was also considered to be the same portion of the sky where we consider the constellation Orion. There's lots of different names for these stars in the sky. A lot of the ones we're going to be using are going to be Greek or Roman or Arab names. A lot of the stars have Arab names to them, and that's great. That's what's cool about astronomy, is that every culture gets to look at the sky. If you were to see the sky in just constellations, it would look something more like this. This is what is considered to be the modern Western astronomy version of the sky. We're looking at a portion of the 88 total constellations that exist in the Western astronomy. If I bring up a different cultural cylinder, let's call it, the sky will look very, very different. We can do that if I... Up, here comes the thing in the song again. There it was, that weird... I don't know why it does that. That's just the way the song is. I'm sorry. So, let's look at the sky a little bit differently, shall we? Let's bring up the Arab sky. You'll see some of the similarities. Orion's there, Leo the Lion. These are all considered Arab astronomy. What if we bring up Chinese astronomy? Wait a minute, what in the world just happened? It's all the same stars, but the shapes are different. And that's why I find this great. Astronomy is a good gateway to a lot of different things. You can study history of cultures. You can study math, you can study straight sciences, you can study astrobiology nowadays. You can study astrophysics, which is what I studied. The actual motions of these objects and how they are formed and why they move around. Or you can just be an artist and be inspired by these different shapes and deities that were considered to be in the sky. Or you can study the literature behind them. Let's look at Inuit, Native American. Now, unfortunately, some of these are not complete, and they are missing. Navajo, the great Diné people of New Mexico and Arizona and Utah and Colorado. Again, not a complete piece of the sky, unfortunately, but there are some stories that exist, and I wish I knew them all. One day, I want to be the Pokemon master, but when it... Not Pokemon, I want to capture all the star stories. Gotta catch them all, gotta learn them all. This is, again, the western sky. It's just an incredible imagination needed to see some of these things. We're gonna find our way around using the constellation Orion, and the reason for that... got a frog in my throat. Ribbit. Ribbit, ribbit. There we go. Got rid of him. The reason we use Orion is because it's easily the brightest thing and easiest thing to see in the winter sky. Now, we are going to be going into spring very, very soon. So Orion and a bunch of these constellations that we're going to talk about today, they're going to be leaving the sky very, very soon. So please get out there and look at them when you can. Orion is the great hunter. There are 4 stars that make up his body, and then 3 stars that make up his belt. So a total of 7 stars, and it makes it really easy to find him. You can either look for the 4 bright stars that make up his body along the outside, 1, 2, 3, 4, or in particular the 3 stars right here, right down the middle, what is known as Orion's belt. That is just a portion, what is called an asterism. This belt and all of these stars are really, really important to find your way around the winter sky. The Betelgeuse is his shoulder star. You don't want to say it 3 times fast. Betelgeuse, the shoulder star, bright red giant. Bellatrix, the opposite shoulder star. Rigel, his knee. And Siph, his other knee. The belt stars Alnitak, Alnilam, and Mintaka. Their names do not matter. But the point is that they have names from many, 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 many years ago. Because they're so easily seen. Some stories have him carrying a club, others have him carrying a sword. Up high in the sky, he's also either got a shield or a lion pelt in front of him. Lots of different variations on the story as to why Orion's in the sky. What I do care about is using Orion to find our way around the sky. This week is actually the best week to look at the sky, and the reason for that is there is no moon. The moon is our natural satellite orbiting around our planet Earth, and it does reflect back sunlight. Unfortunately, for the moon, we don't get to see it for the next few evenings because it's in the same part of the sky as the sun. A phase called new moon phase. But because of that, it means the sky is beautiful to see the stars and see objects that are very, very far away. So let's start let's use Orion. And let's find 2 dogs in the sky. Okay, we're going to start off with the belt of Orion and draw a line through them towards the eastern horizon. So this way. And we stop at a nice bright star that will make my dog look up at me when I say it. This is the bright star known as Sirius. That is my dog's name, and that is the bright star in the large dog Canis Major, Orion's big hunting dog in the sky. Go back to Orion, but this time draw a line from Sirius to Betelgeuse. Nope, not that way. We want to draw a line from Sirius to Betelgeuse. Stop in the middle, head this way. We're going to make a triangle. This is the winter triangle. We've been talking about it for weeks, but it is now going to be getting lower and lower and lower as we head out of winter and into spring in the northern hemisphere. Sirius, Betelgeuse, and Procyon. Procyon is the brightest star in Canis Minor, the little dog, which is actually just a dachshund, I guess, because it's just 2 stars in the sky. Get rid of the thing. Come on. There we go. So, we've now found Orion, we've found Sirius, and we found Procyon. So we found 3 constellations so far. Draw a line from Betelgeuse through Scythe. Now, remember, Scythe is the slightly dimmer star of his knee. Draw a line this way, and you end up inside of a rhombus-looking shape. You'll see there's 4 stars. 1, 2, 3, and 4. That is actually the body of Lepus, the hair. It's a little bunny rabbit just below Orion, and you can kind of see his little bunny ears heading out this way, and his body this way. Hind legs or a tail going back that way. Going above Orion, draw a line from Rigel, his other knee star. Come on. Through Betelgeuse and keep going. You end up next to 2 parallel stars. They're the brightest stars in this part of the sky, so you really can't miss them. One is named Castor. The other is named Pollux. They are the Gemini twins. They are right above Orion. I think there's actually a dog food brand now named Castor and Pollux, but that's where they get their names from, these 2 stars, Castor and Pollux. Pollux is the one on the left. They are virtually right above us, so you'll see the planetarium having a problem kind of pivoting because they're right at the zenith, right at the top of the sky this evening. There's another bright star and a constellation right above Orion. If you draw a line through Scythe, come on, line drawing thing, Scythe, his knee star, up through Bellatrix, and keep going up this way. But I need to move the planetarium, so I apologize. Let's rotate it slightly this way. Again, draw that line out through Scythe, through Bellatrix, kind of between the 2, to be honest. Between Betelgeuse and Bellatrix. Draw the line up this way, and you end up at a bright star named Capella. Capella is a bright star in Auriga, known as the Charioteer, but weirdly he also has a goat with him. Capella is supposedly that goat. So a nice bright star right up there. And his shape looks more like a home plate kind of thing. A little bit easier to see. Again, if you were out away from the city lights. And finally, we're going to find a constellation known as Taurus the Bull. This is a really easy one. Just draw a line through the belt. Earlier, we drew a line through the belt towards the eastern horizon and found Sirius. This time, we're going to draw a line through the belt and head towards the western horizon. We're going to find a V of stars and a little patch of blue stars. Remember earlier when we started out the show, we talked about the Hyades and the Pleiades? Well, there they are. The Pleiades, the 7 sisters, or Subaru, are this little beautiful open star cluster. We saw there was lots of gas and dust around everything. I clicked on Alcyone because, well, that's one of the 7 sisters. Also the name of the cat. We have a star cat and a star dog. We're nerds, and we love it. This is an open star cluster. You'll notice the stars tend to be brighter blue in this particular cluster. That means they are a younger star cluster. Stars live by the live fast and die young mentality. Stars that are blue are very, very hot. They do not live very long. And what do I mean by very hot? Hot. I mean they are hotter than the sun. Our sun is considered to be a yellow dwarf star, and so it's kind of an average star. Everything that's more towards the blue and white colors are going to be physically hotter than the sun. Anything cooler than the sun, not like, hey, Joe Cool, I'm talking just physically colder than the sun, they're going to be more red and orange colored stars. Like Aldebaran, the face of Taurus the Bull, is made of the Hyades, and Aldebaran is the red giant star in the Hyades. You notice the Hyades, also an open star cluster, you don't see them glowing as brightly blue. This is an older cluster of stars, and it does make a V shape, which is pretty cool to see. And that's supposed to be the face of Taurus the Bull, and the Pleiades are riding on the bull's back. In some stories, Orion is trying to woo the Seven Sisters for one reason or another. Now, we'll talk about star life and death cycle a little bit later. Well, I guess I could talk about some of it now. One last thing I want to talk about before we go further away from here. We're going to go back to Orion. We've drawn a line through his belt to find various things. Now we're just going to find the belt, the 3 stars of the belt right here, and go straight down. That's it. That's all you got to do. Even with a small telescope, if you are able to point it towards the center star of the belt and then go straight down, you will find this little cradle right here. This is a stellar nursery. Look at the baby stars being born. Okay, they're not really born, they form. But this is an area where stars are currently being born. They're currently forming. This is a nebula. This is what's left over after a star dies. There's a couple of different ways stars can die. When they grow older, they cool off and they turn into what's called a red giant. So they physically puff up, trying to stay together to keep the internal pressure of the star going. And if they can no longer keep that pressure up, they can no longer fuse elements together to create energy, nuclear fusion as it is called, they can lose equilibrium and become what's called a planetary nebula. They just kind of puff out into space. Other stars, they can die violently. If they're really, really massive, they will explode violently. We'll look at one of those in a second. But over time, that gas and dust will float around and eventually start to recoalesce into new stars. And that's actually what's going on right here in Orion. That is there. Orion's just full of cool stuff. There's the Witch's Head Nebula. Right over here by his knee star, Rigel. And then up by his belt star, Omnitak, you have something that many of you have probably heard of before. The Horsehead Nebula. It's right here. It's upside down. In this case, it looks like a scorpion's tail. But, yeah, that's a star-forming region right here. You got hydrogen alpha, that bright red color. You remember I said hydrogen alpha filter for the sun earlier? Hydrogen alpha is a excited state of hydrogen. Hydrogen's the most common element in the entire universe. It's just a hydrogen atom. It's a proton with an electron floating around it. Pretty simple. But when the electron gets in an excited state, it will give off a reddish glow like this. And so you see it on the surface of the sun, you see it in space. Very, very cool. Now, when stars do explode violently, where's my little search thing? Because I don't feel like clicking on it the other way. There it is. It's actually right above Orion as well. This was actually something that was spotted long ago by Chinese astronomers. They saw a bright star appear in the nighttime sky, and it stayed there in the daytime sky before the sun would set, and no one knew what the heck it was. And then years and years later, somebody discovered this cloud in space. And it took a long time for people to put 2 and 2 together and realize that the bright star that appeared in the sky and then disappeared was actually an explosion of a star. In this case, a supernova. The star exploded violently. This is called the Crab Nebula. Crab people. This is an area of space that's going to be highly irradiated. A lot of energy floating around. But from these explosions, you get really, really heavy elements on the periodic table. Things like uranium and plutonium and thorium. And of course you have all the elements you see were all formed in stars. All the elements of the periodic table were all formed in stars at some point. In particular, iron is really important. When stars get to the point where they can fuse iron into other elements, they start losing energy and they start turning into red giants. They start to die. There's iron in your blood. We are stardust, my friends. It's always important to remember you're connected to the universe because you are stardust. Or star stuff, I believe is what Carl Sagan called it. We drew the line through Orion's belt and found the Pleiades. And a few nights ago, you would have found the planet Mars right below the Pleiades, but Mars is currently drifting. You'll see Mars is right by my mouse, right over here. Mars will be drifting further towards Orion, towards the left, but not towards Orion itself. You see, the sun, the moon, and the planets all travel along an arc in the sky. This arc follows the sun, but the moon and the planets seem to follow the same exact arc. That arc travels through a set of constellations. There's technically 13 of them, but one of them was dropped for obvious reasons. There's 12 of them now. There's 12 months of the year. There's 12 constellations the sun travels through. We call them the zodiac constellations. Taurus the Bull, Gemini twins. We've talked about a couple of those. Cancer the Crab is out tonight. Leo the Lion's out tonight. Virgo rises up around midnight, give or take. Actually, she's already rising up at 8 o'clock, give or take, so there you go. But why? Why are these constellations important? Why do the planets travel through them? The word planet comes from Greek, so the Greeks looked at the sky and they called all of these objects asteres, stars. Some of the objects that moved around were called planetes asteris, wandering stars. That included the sun and the moon, because they wandered through the sky. Now, obviously, we don't consider those to be planets today. Sun, moon, and 5 other objects, what we now call Mercury, Venus, Mars, Jupiter, and Saturn. That's a total of 7 objects. There's 7 days of the week. Each one is named for a planet. Classical planet, as they were called. So sun is Sunday, moon Monday, Tuesday is for Mars, Wednesday is for Mercury, Thursday is for Jupiter, Jueves, if you speak any of the Romance languages, or Spanish, for example. Jueves is referring to Jupiter, so that's going to be Thursday. Friday is going to be Venus, Viernes, and Saturday, Saturn, Saturn's Day. Go figure. So every day you actually talk about the planets, and you never really thought about it before, but now you do. Looking at our solar system from the side, you can see all the planets appear to be on a nice flattened out plane. Imagine you are making pizza. Doesn't matter whether it's regular pizza, keto pizza, doesn't matter what it is. You're going to want to flatten out the dough. Now, if you're doing it the old-fashioned way, you're going to be tossing the dough up into the sky and spinning it around. Centripetal force will flatten it out. That is kind of the same idea here. As the solar system has coalesced into the planets and other objects, all the planets appear to have kind of flattened out along the equator of our sun. This is why they all travel along the same path in the sky. This is the plane of the ecliptic. This is the zodiac. Let's look at each of these up close. Let's start off with the sun, which we were looking at earlier. Again, do not stare at the sun. I take no responsibility if you damage your eyes. That is on you. Please don't do it. There's the sun. You see it kind of bubbling up and stuff going back under the actual surface of the sun. We're going to spend a whole couple of episodes. We got an Astral 101 program coming up very shortly. I'm editing the last couple of videos. We got 3 videos to start that out. We got kind of a primer just saying, here's what we're planning to do. And then we have video number 1, kind of introducing you to astronomy. And then video number 2, kind of talking a little bit about the math and the sciences within astronomy. Excuse me. And so eventually we're going to get to a section where we will talk about each object in the solar system individually. So we'll spend a couple of episodes on the sun itself, looking at stuff from SOHO and old diagrams and new hypotheses about the solar system itself. Let's slow things down a little bit. Let's visit some of these objects. Now, Mercury, Venus, Earth, and Mars are considered to be the inner solar system, the terrestrial planets, terra meaning Earth-like. You can't see Venus right now. It is too close to the sun from our point of view, and so even if it's daytime or nighttime, you really can't see the planet, for the most part. Not a recommended thing to do. But we're going to start out with Mercury, which looks like this. Little scorched Mercury. Way too close to the sun. Very hard to see. You can see it for the next week or so in the early morning. I'll show you when we get back into our planetarium how to find that in just a little bit. But there's Mercury, heavily cratered. Any atmosphere that may have been around this planet got blown away as the sun heated up. Get out a little bit further, we get to the evil twin of our planet Earth. We get to Venus. Now, Venus is the brightest object at night. That's not the moon. You see Venus in the early morning, right before sunrise, or you see Venus in the early evening, right after the sun is set. Because it's closer to the sun than we are, we only see it very, very briefly, but it is extremely bright. Sometimes it's called the morning star. Sometimes it is called the evening star. It is not a star, it is a planet. It is rotating the wrong way. So if you look at the planet Earth, Earth rotates, let's say this way, from left to right. Venus rotates from right to left. Why? Nobody knows. The sun would rise in the west and set in the east on the planet Venus. That's very weird. It also rotates really, really slow. Its day is almost as long as its year. It's just a very, very strange planet. This, of course, is our little blue marble. Let's slow it down a little bit. This is our planet Earth. This is our home, which we should take care of. Light pollution does make a kind of an interesting thing when you look at Earth at night. It looks something like this. You can see major cities just by the glow that they give off. But you don't see that during the daytime because, of course, there's no city lights during the daytime. Just an interesting observation. So there's the Earth at night, and there's our planet Earth. Let's go and find the planet Mars, which we briefly talked about a little while ago. There's Mars. Now, Mars, which is again out tonight, which we talked about just a little bit ago. Mars, can we pause it? Yes, we can. Mars is about half the size of the planet Earth. I said pause. There we go. And it has some very interesting features on it. You can't really see them all that well unless you have a really big telescope. There is a huge crack along the surface. Look at the United States map. Maybe you're not from the United States. Look at a map of the world. Look at the United States. Imagine San Francisco on one side. Imagine New York City on the other side. That's the entire United States. Well, this crevice right here, that is Valles Marineris, Mariner Valley. It would cross the entire United States. It's about 8 kilometers deep. It's about 5 miles for people that like to use the imperial measurements. Here we have Olympus Mons, this large shield volcano up top, and 3 shield volcanoes nearby. This whole area is called Tharsis, and it is where you find all of these interesting volcanoes. No wonder you couldn't see. Thank you for pointing that out. My mouse wasn't showing up, and here it is. Now you can see my mouse. I had to click a button, apparently. But there we go. This is Tharsis up here. Now, if you look at the map of the United States, once again, look at the southwest. You've got 4 states that hit along very, very even lines, the 4 corners region of the United States: New Mexico, Colorado, Utah, and Arizona. Any of those states, you could take this volcano and place it, and it would take up the whole state. This volcano's huge on this little tiny planet that we call Mars. Now, once you pass Mars, Let's reset this to give you guys you wonderful people, I should say, a much better view of things. There we go. We got the rings back here to see the orbits. This huge cloud of stuff right here, this is called the asteroid belt. Some asteroids are exactly what you think. They're kind of like oblong or potato shaped, or they're just kind of chunks. But then there's little planetoids like this, where they are actually rounded. Very, very interesting. Some people think there may have been another planet that maybe got destroyed. Others say there's not enough material here to form another planet. I don't have that data, so I can't really tell you much. Some of them are named, like this one right here is named Vesta. You can see it does have a rotation. It's a planetoid. This is what's called a minor planet. Pluto is now considered to be one of these dwarf planets. Ceres is another one of these objects that was big enough to be noticed, but not big enough to actually be a planet. It's interesting because these objects out here, they are heavily mineraled. The future is not strip mining our beautiful planet. The future is going out and mining these little worlds and then bringing back materials. Irons and gold. There's gold in them thar asteroids. And silver. And lots of things that are used in manufacturing. So that may be the future. Once you pass the asteroid belt, you end up where the gas giants live. Gas giant planets are huge. They rotate very, very fast. And we cannot see their surface. If they have a surface, it's hidden deep inside of this huge cloud. This particular planet is Jupiter. It's not the best look at Jupiter, unfortunately. It looks kind of like it was painted because this software is kind of screwy. They did a good job on the inner solar system. The outer solar system's a little suspect. A little bit, just a little bit. There is one interesting thing, the Great Red Spot. Let's pause it right there. Can we do that? We can. That's the Great Red Spot. This storm would cover up the entire Earth 4 times. You could fit the Earth in it 4 times, I should say. It is huge. It's a hurricane-like storm in the southern hemisphere. There's a couple of other objects that are like this. Saturn has a couple of smaller ones, and oddly enough, Neptune has one that we call the Great Dark Spot. Now, as I said, it doesn't always represent these outer planets very well. And so I'm going to cheat. And I'm going to go find a picture of Saturn, because Saturn's the next planet on the list. However, I don't like the way it looks in the software. And it makes me feel bad. So, we're gonna find a picture of Saturn, and then we're gonna look at that instead. Is that okay? Everybody okay with that? Okay. There we go. There's our picture. So let's see here. Where's Saturn in this software? Saturn is back here. You'll see why in just a second. Oh god, there's no rings on it. They didn't put any rings on the planet Saturn. So the outer solar system planets, Jupiter, Saturn, Uranus, and Neptune, they all have ring systems. Saturn's is, frankly, the most beautiful. The rings are made of dust and gas and ice, mostly ice in Saturn's case, reflecting back a huge amount of sunlight. And when you look at it through a telescope, it is just mesmerizing. Jupiter, Uranus, and Neptune's rings are not very bright. You cannot see them, especially Jupiter's rings are just dusty. And so you can't see them through a telescope. But Saturn's very easily seen. You see the Cassini division, this dark ring right over here, and the Encke gap out here. Saturn is just incredible. I can't wait to talk about this in the Astronomy 101 program that we're going to be doing, because we're going to get to spend like a week or two, maybe 4 or 5 episodes, 30, 40 minutes each. Just, there's a huge amount of data to go through, huge amount of photos, and Saturn's my favorite, so there's that. Shouldn't play favorites. But when it comes to observing, Saturn is my favorite to see. Unfortunately, this software did no justice to it, so we shall leave it behind. Uranus, the next target of our solar system trip. Uranus is another one of these oddball planets. Venus rotates backwards. Uranus rotates on its side. Imagine North Pole up top, South Pole on the bottom. Well, in this case, the North Pole would be here in front of us, and the South Pole would be back here. So half the year of Uranus, which is much longer than an Earth year, it's 82 years for Uranus to go around the sun. Half of the year, the North Pole faces the sun, half the year, the South Pole faces the sun. So part of the year, the equator faces the sun. Like, it's just a really weird planet. We don't really know much about why that happened. Gravitationally, something had to have gone by to yank that planet and ripped it the whole thing over. All the moons that go around that planet are also on its side, and the rings as well. Rounding things out, we've got Pluto, Neptune, I should say, named after the god of the sea, Poseidon, or Neptune, hence the blue coloring, is why we got the name. It does have a dark spot, not represented on here again. They kind of didn't do a good job on the outer planets, but that's okay. Very odd planet. It's about the same size as Uranus, but it seems to have more cloud activity, so there's something heating up the atmosphere. Maybe it's shrinking, we're not really sure. And even though it's no longer considered a planet, we're going to look at Pluto anyway, because this is my planetarium, and we're going to look at Pluto. Pluto is a small little object out at the edge of the solar system in what is called the Kuiper Belt. Used to be a planet. It was discovered by Clyde Tombaugh, who used to be a resident of the state of New Mexico. A lot of people here still consider it to be a planet, even though it is demoted into the dwarf planet category, much like Sedna and Quaoar and all these other objects, Makemake, all these other objects that are out here. That's actually the name. Don't at me. That's actually the name. It's Makemake. There it is. You can see it. The name's on the bottom right. Makemake. So far out. Look at how far away we are from the sun. The sun's just a little dot now. Out here, again, is what's called the Kuiper Belt. This is where the dwarf planets live, and you start to find comets out here. Not represented here. There's actually a huge cloud out here called the Oort cloud. It makes a shell around our solar system. That's where the comets truly live. They live way out at the edge of the solar system. As you see, we're now exiting our solar system, and now we see that our sun is just a simple star all by itself. Weirdly, a lot of stars are formed in pairs or in triplets. You have, binary stars, 2 stars, or trinary stars, 3 stars. 2 of them act as one star gravitationally, and the other one orbits around them. Our sun is all by itself with just this little family of planets around it. But what about all these stars out there? We talked about some of them. We call them constellations, the shapes that they make. But what are the stars? Keep that in your mind for a little bit. Let's come back to the planetarium, advance to morning time, and look at the other planets, and then we'll come back and finish up. How about that? Again, if you have any questions, stop me at any point. I don't mind talking about whatever you'd like. At any point. Let's rotate towards the east-northeast and talk about an asterism. Now, an asterism is not a constellation. It is a portion of a constellation. Orion's Belt, for example, is an asterism. Everybody knows how to find it now. It's 3 simple stars, but that's not a constellation. It's a portion of one. Possibly the most other famous thing in the sky, other than Orion and Orion's Belt, is what's called the Big Dipper. The Big Dipper is not a constellation, but the Little Dipper is. I don't make the rules, I just teach whatever I can teach. The Big Dipper... Yes, those are satellites traveling through our planetarium. Don't freak out. There are no aliens on our dome. But are they out there? We don't know. The Big Dipper is 4 stars of the cup, 3 stars making a tail. There it is. You see it's part of something bigger called Ursa Major, the Big Bear. The Little Bear is Ursa Minor, which again, it's just the Little Dipper. Why is there a difference? I don't know. I didn't make the rules. I think that's weird. But why does this matter? Well, we can use the Big Dipper to find what is called Polaris. Polaris is the North Star, the Pole Star, the Lode Star. We're also going to use another constellation in the sky to find the North Star as well. There's two different methods of doing this, and these objects are opposite of each other in the sky, but you have to be able to find north to do it. So if you can find the Big Dipper, or if you realize that the sun's set in the west, that should be to your left if you're facing north. So if the sun's setting and you turn and it's to your west, to your left, then you're facing north. But how do you know you're facing true north? Find the Big Dipper. Where's my little drawing tool? There it is. 1, 2, 3. There's 3 stars of the tail. 1, 2, 3, 4 stars of the cup. These last 2 stars, we call them the pointer stars. They point to Polaris. Draw a line like that. Boom. You draw a line straight to Polaris. Now, you have to understand that in the dome, it's going to look a little bit different than it does in real life. Your open hand, like if you're able to, hold your hand up towards the sky. Do the anime protagonist and like hold your hand up towards the sky, right? Well, this distance right here between these 2 pointer stars is going to be about the size of your palm, give or take, depending on the size of your hand. That's kind of visual astronomy. So your finger is about 1 degree, your palm is about 5 degrees, and you'll notice that this thing says they're about 5.5 degrees, give or take, apart. So it's about the width of your palm. So you got to understand the Big Dipper is huge in the sky. Draw a line through these and you end up at the North Star. There it is. There's Polaris. It is not the brightest star at night. That is the title held by Sirius. Now, there is another group of stars I want you to be able to find. It is opposite of the Big Dipper. You see the Big Dipper hanging out over here on the eastern side of our planetarium. On the western side, you're going to see an E. Oh, that's not it. An E. Well, this looks like a W when it's low, or a 3 when it's in the east, or an M when it's high. This shape is Cassiopeia, a queen in the sky. You'll notice she's upside down because she's being punished. Half the time she's right side up, she's beautiful, she's staring at herself in a mirror. And the other half of the time she's upside down, holding on for dear life, and, snot running out of her nose. Never a pleasant story, but when you make fun of the sea nymphs and make fun of the goddesses, they can be a little bit vengeful. So Cassiopeia's in the sky, right? And she's made up of 2 triangles. Try to use these simple shapes. If you can connect 3 stars, you can make a triangle, right? 1, 2, 3. That's an equal-sided triangle there. 1, 2, 3. That's kind of a not equal-sided triangle. That's more of an obtuse triangle. That's how you get Cassiopeia. You can draw a line through these triangles to get to the Little Dipper. And more importantly, to Polaris. Where's my little drawing tool? Draw out that triangle, and then draw a line right through the middle of it. Boom. Use either triangle, draw towards the open end. It helps if you know where the Big Dipper is, and again, it depends on where you live. Sometimes if there's objects in the way, maybe mountains or hills or buildings, if one is higher up, then the other one's going to be lower, so you can kind of help pinpoint the North Star by using both of these objects. As we put time in motion here, you see the planetarium rotating, you see the stars getting higher and Cassiopeia is getting lower, but Polaris basically stays in the same spot. Hence the Pole Star, the North Star, it's always kind of going to be in the exact same spot. In reality, it does move ever so slightly, but not really enough to be noticeable from our point of view. And that's why we use it for navigation. Now we've advanced to about 5 in the morning, give or take. It is 5:15 in the planetarium. Sorry, 5:12 in the planetarium. We are now looking towards the east. And the moon is actually still out, so I lied a little bit earlier. I said it was in new moon phase. It's in waning crescent moon phase. We'll talk about the phases of the moon in just a second. But before sunrise, today and tomorrow, you will see the moon in the sky with the planet Saturn, the planet Jupiter, and the planet Mercury. The moon, of course, looking like a waning crescent, just a little crescent in the sky. Beautiful, beautiful moon. I love the moon, hence the name of the channel. Saturn, we talked about a little bit ago. Saturn and its rings. Saturn has a huge family of planets around it. The largest moons around it. The largest moon around it is known as Titan. It has an atmosphere. Titan's way up here at the top of the dome right there. Titan has an atmosphere made of methane. It rains methane. There's lakes and rivers of methane on Titan. What a strange little world. Jupiter we looked at a little bit ago. Great red spot not visible at the moment. It's on the other side of the planet. 4 moons around Jupiter, easily seen through a telescope. We call them the Galilean moons, or the Galilean moons, named for Galileo Galilei. Discovered them in 1610. Io, Europa, Ganymede, and Callisto are their names. Io is a volcanic moon. Europa is a frozen ball that likely has an ocean of water under it. Ganymede is the largest moon in the solar system. In fact, it's actually a little bit bigger than Mercury. And then Callisto, slightly smaller than that. Those two are also icy moons. We're not really sure they'd have oceans of water under their surface, but they do have some sort of water. But we're pretty sure Callisto has a crust of ice. Europa has a crust of ice and an ocean of water under it. Oddly enough, there's actually a moon around Saturn called Enceladus, which also has kind of a similar setup, a crust on the surface, and then likely water ocean under it. And there's scorched Mercury, which we looked at a little bit earlier. So again, you can see this scene tomorrow. You'll be able to see this for the next few days, because Mercury will move very, very fast from our point of view. Really quickly, let's look at the moon. And by that, I mean... let's look at the way the moon goes around the planet Earth. Where is my little moon applet thing? Let's take a look at that. There we go. Again, my apologies. There's some weird things going on with our software today, so we're just gonna wing it and do the best we can to make sure you guys and girls and non-binary friends, other humans, that you all get to learn a little bit about where to look in the sky. Let's switch to the other software real fast, so let's get rid of that. Yes, good. Again, if you have any questions, if I haven't answered them outright, just feel free to stop me or post them up. Here's a look at the Earth-Moon system. See the moon hanging out way back over here. There's our friend the moon. People say there's a dark side of the moon. That is not correct. As the moon orbits around our planet Earth, it keeps the same face looking towards us. We call that tidally locked. So this is the face you're probably used to. You see the craters, and you see the lunar highlands up here. Huge craters, these dark areas we call the seas of the moon, the mare. People thought they were filled with water. They are not. They are filled with lava, but the lava has eventually solidified into rock. We are now going to orbit around the moon and watch as the moon orbits around the Earth. You'll see that the backside of the moon, which is what we're coming upon here, does get sunlight during what we call new moon phase. So it's not really the dark side of the moon, but it is heavily cratered. It does get sunlight for about 2 weeks, give or take. That is the interesting thing about living on the moon, is that it takes an entire month for a single day on the moon, an Earth month for a single day on the moon. So that means you spend 2 weeks in sunlight and then 2 weeks in darkness as you go around the planet Earth. How do you go around the planet Earth if you are on the moon? Well, it looks a little something like this. Here we are looking at a very basic moon phase simulator. This is not mine. The sun is off to the left, hence the sunlight. The Earth looking at the North Pole. There's us. There's a human right there. And the moon orbiting around us. As the moon orbits around, it does reflect a different amount of sunlight. The bright side on the right side we call a waxing moon. So start off with a waxing crescent, and then you hit the first quarter moon. So it's gone 1/4 of the way around our planet. Hence the name. So there's 90 degrees right there. So there's your first quarter moon. So that rises up around noonish, and you see it at sunset directly in the south. Now, when you get to what's this phase right here is called the waxing gibbous, so it's not full, it's not a crescent anymore. It's in between. When you get to the time when the moon rises at the same time the sun sets, we call that a full moon. They are in opposition. They are opposite of each other in the sky. The entire lunar surface is visible. We see it rise up every month. At least in the northern hemisphere, we have a different name for those moons. So the first full moon of the year in January, we call that a wolf moon. The February moon is called the snow moon. Obviously, lots of snow in February in the northern hemisphere. The March moon, so in 2 weeks on the 28th of March, will be the full moon for this month, and it is actually called the worm moon, because this is when the soil begins to start to thaw, and you start to see worms coming out of the ground, because we're approaching spring, so the worm moon. Coming up in just a few weeks. We'll talk about that as we get closer to it. The phases go in reverse now. We go from waning gibbous into a waning crescent. Along the way, we stop at a third quarter moon, which looks like this. It's gone 3/4 of the way around our planet. Again, this entire journey takes 28, 29 Earth days. So what we call a month is actually just tracking the lunar cycle. Now, the way the calendar works and the way the moon moves around doesn't always line up. So this month we started out with a third quarter moon, oddly enough, and now we're in the second week of the month, and we're going to have a new moon. New moon is usually when the cycle starts, so it's a little bit off, and that's okay. There are occasions where you actually get 2 full moons in a month, and that second moon is called a blue moon. I am not going to sing it because my voice can't take it at the moment, but you know the song Blue Moon. That is what it's named after, is a second full moon. So some years you get 13 full moons instead of 12. And again, remember I said there were 13 constellations of the zodiac, but that was reduced to 12. There you go. That 13th constellation is Ophiuchus, and it's one of those constellations you do not want to bring up in a planetarium, because most of the time his artwork has him holding a snake around his waist. You're really hoping that the artist put clothes on him. And the answer is yes, he has a loincloth. Thank the universe. Right here. Thank you. So these are summer constellations that are going to be rising up, and actually if you're up around midnight or 1 in the morning, you will see Scorpius or Scorpio. It's a bright, literally a J of stars. You cannot miss this. Bright J of stars, and a heart star named Antares, which literally means anti-Aries. It looks like Mars, but it's not. Bright red in color, but not a moving planet. Let's actually look at the stars themselves. That's actually the next phase of our show. We looked at the moon, we looked at the constellations, we looked at some planets. Let's actually get rid of all of these things, get rid of all the simulations, and let's just get a blank canvas, shall we? We're just floating in space. Isn't that pretty? That's the Milky Way galaxy, by the way. We're going to talk about that in just a second. A galaxy is a collection of billions of stars and likely trillions of planets around those stars. Gas and dust. Whoops. Gas and dust all the way around. They come in different shapes and sizes. Again, we'll look at that in just a second. We are just floating in space. I'd invite you right now to just take a deep breath. Take 3 deep breaths, hold it for 3 seconds each time. So ready? Deep, deep breaths. Relax. Become one with the universe. A couple more breaths. Want this to be nice and relaxing and educational and fun, hopefully. We're going to look at the sun. Well, I guess we should... Well, let's go back to where we were before. Change of plan. We're going to go back to the solar system. I want you to understand how big stars can be. We mentioned Antares, we mentioned Betelgeuse, we mentioned Aldebaran. This is our solar system. We're going to do something really bad. We're going to replace the sun with a red giant. So look at all this space that's between Mercury and Venus and Earth and Mars, the asteroid belt and Jupiter. We're going to pause the simulation so nothing explodes, because explosions do happen in here. Again, explosion! Let's look at Betelgeuse. This one star is the size of the orbit of Jupiter, give or take. The sun is deep in the middle there, and then you got Mercury, Venus, Earth, and Mars, and the asteroid belt, and you still haven't exited the star. This is a red giant. These things are huge. Stars get very, very large. So now we've seen the example with our solar system, let's come back to just a blank canvas and let's look at some stars, shall we? Let's put out the sun. We talked about the sun. That's our star. It's our friend. Gives you a little cancer now and then, but it's still our friend. Heats up our planet. Gives us something to see in the daytime, which you shouldn't stare at, but it does give us something to see. We're going to pause it, and we're going to put another star. We're going to put that star. We talked about the sun. Let's look at Rigel. Well now, Rigel is the knee of Orion, isn't it? It's a little bigger than the sun, isn't it? Look at that. But you'll notice it's a bright blue. And what did we say earlier? Blue stars, are they hotter or colder than the sun? They are hotter, that is correct. What about one of these red stars? We talked about Betelgeuse, that's Orion's shoulder star, right? Well, look at that. We looked at it in the solar system, but we're just going to kind of pile up a bunch of different stars here to kind of compare sizes. Antares, the heart of Scorpio, we talked about that. It too is a red giant star. We believe it's about the same size as Betelgeuse. These stars are not in these positions in reality. We're just kind of using this software to put them all out. Here's something interesting. Let's take a look at the sun, and then we're going to go to Spica. Spica is a star in Virgo, which rises up again around 9 o'clock tonight. We didn't really talk about it, but we'll talk about that in extensively in the next few weeks, because it's a springtime and summertime constellation. Smaller blue star than Rigel. Notice a difference in color. This one is blue. This one's a little more bluish white. Why? Again, temperatures, sizes, pressures. What else do we talk about? We didn't talk about Deneb, but we just want to put Deneb here. You can see it's a larger blue star. So stars can be smaller than the sun and still brighter. Some can be bigger than the sun and brighter, hotter. Some of them are smaller. Then we got a star like Vega. Vega we'll talk about in the summertime. Vega's this little tiny blue star. Look at all of these different stars compared to our sun. Look at how small the sun is compared to all three of these. Now, they're not in these positions, obviously. I'm just kind of throwing them all out there. I just want you to kind of get an idea that our solar system, in some respects, may actually be rare. These red giant stars that are out there, there's not likely a solar system around them. They've probably consumed whatever is around them. Now, there is a flip side. There are... Oh, we mentioned Sirius. I didn't even put him out here, did I? There's Sirius. There's my little buddy. There's Sirius. Alcyone is not in this, unfortunately. There is one called Wolf 359 that I would like to put out there. Not because it's all that impressive, but because if you're a Star Trek nerd, you know all about Wolf 359 and the battle that ensued there. If you're not a Star Trek fan, you should become one. There's Wolf 359. Wolf 359 is a small red star. So let's compare. Look at that. That's a red giant star back there. And this is a main sequence, just cold red star. That's a star back there nearing the end of its lifetime, and this is a star that's just kind of chugging along. Again, stars live by the live fast, die young principle. If you are a young, hot blue star, you will not live very long, just a few 100 million years. If you are a red star, you will live a few billion years. If you're a yellow star, you're kind of in between. Our sun, at least mathematically, it's been decided that the sun is about 5 billion years old and has about 5 billion years of fuel left before it goes from being this little tiny yellow dwarf star into one of those behemoth red giant stars back there. Some of these other stars that we talked about, like Sirius or Rigel or Deneb, these blue stars we see in the back here, Spica, they won't live that long, and they will quickly go to 300 million years, go from this into that, and go kaboom. Big bada boom. Wolf 359, it's a red dwarf star. It will live a very, very long time, supposedly, at least mathematically and cosmologically. There are red dwarf stars that have been around since the early formation of the universe. And that's what we're going to talk about next. We've talked about planets in our solar system, and we've talked about other star systems in the sense of we looked at how stars are in comparison, as we see here. There are star systems out there. There are other planets around other stars. We call them exoplanets. When I worked at a planetarium long ago, I remember the joy that we had when we hit 100 exoplanets discovered. That's not the case anymore. There are many, many, many planets that have been discovered around other stars. Are they habitable? In many cases. For humans, no. For other things, who knows? That's the terrifying and amazing part of astronomy. The distances between these objects are all very, very huge. And so we can't travel yet till we discover ways of traveling the stars. Now, that big cloud that we see in the background, that is a collection of all the stars, gas, and dust that we see at night. We call that the Milky Way. And so we will now take a deep breath. Remember, take 3 deep breaths. And we're going to load up this. We're going to zoom out a little bit more. Our star, the sun, is but one little tiny dot, not even visible at this scale. In this, what we call a spiral galaxy. Now, spiral galaxies don't all look like this. Some of them have what's called a bar down the middle. It looks like an actual physical looking bar of gas and dust kind of spiraling around, making a barred spiral. I can't show you that right here. Just trust me. You can look them up on Astronomy Picture of the Day. Remember, we looked at that website earlier. Use that and type in barred spiral. B-A-R-R-E-D. Barred spiral. But the general idea is you get a whirlpool-like shape, something like this. We believe our Milky Way looks something like this, but we don't see it this way because we are around a star that is in one of these arms. So from our point of view, we just see an edge-on view. And again, centripetal force. Think of the pizzas. Pizza. Think of pizza. When you spin the dough around, it flattens out. It's the same idea. There are some galaxies out there that look like footballs instead of whirlpools. We call them elliptical galaxies. And then there's a third type of galaxy that's called irregular. It's kind of in between. It's either a collision has occurred and galaxies have been shredded apart, or maybe it just never formed right, or something happened where a spiral became misshapen. We'll look at that in a second. Now, I want you to think about when you write a letter. No one really writes letters anymore. Maybe you order a package or you mail a package to someone for a birthday or, for a gift, whatever. You need to know their address, right? So you usually have your home address, and then you have the actual number of the house or the apartment, and then you have the street address, and then you have the city, the county, and the state or prefecture or ward, whatever you want to call it, and then your country, correct? And then that country is on the Earth. The Earth orbits around the sun, third planet from the sun. The sun is one star in this, the Milky Way. The Milky Way is not alone. The Milky Way is part of something called the local group. The local group of galaxies... We're going to change the way this looks a little bit, so the Milky Way is going to look a little bit worse. I apologize, I didn't make this simulation. There's the Milky Way looking not as cool. But you see this local group of galaxies. These little dots here, they're actually other galaxies that hang out near the Milky Way. They're caught with its gravity. If you live in the southern hemisphere, so if you live in Australia or New Zealand or South Africa or Zimbabwe, anywhere, below the equator, you're going to see the large and small Magellanic Clouds. These are irregular galaxies, chunks of maybe the Milky Way, maybe some other galaxies that came by, and were shredded apart. That's the small Magellanic Cloud, and way back here is the large Magellanic Cloud. We are in 3D space, so this does take a little reorientation. Come back to our Milky Way. Sagittarius Dwarf Galaxy, the Draco Dwarf Galaxy. So the next line of your address, you go the Sun, and then the Milky Way Galaxy, and then you go local group of galaxies. Now, the local group is dominated by another galaxy that's actually out tonight. We'll end with how to find it in just a second. But that galaxy is called the Andromeda Galaxy. The distance from our Milky Way to the Andromeda Galaxy is 2.25 million light years. So what is that? At the speed of light, which is almost instantaneous for our eyes, but you can actually slow it down in water. That's how you get Cherenkov radiation, that blue glow of nuclear reactors. This entire distance, that's 2.25 million years at the speed of light. To get from the sun to the Earth, it's 8.4 light minutes. That's 93 million miles, or 150 million kilometers, in 8.4 minutes at the speed of light. We're talking years. These distances are vast. They are huge, and we're able to travel it in this planetarium or in this software in mere moments. But in a few million years' time, this gap will close because in space, gravity is the thing that controls. It's one of the primary ways things get pulled around. If you have more mass, you have more gravity. I'm a bigger dude, okay? I'm a bigger guy, okay? If I'm around someone small like my wife, I have more mass. Eventually, if we were put out in space, over time, eventually, if we were just left alone, she would float towards me because I have more intrinsic gravity because of my mass. The Andromeda Galaxy and the Milky Way are pulling towards each other. And they will end in a beautiful dance. Andromeda on top here, Milky Way being a bottom here. That's a terrible thing to say. Deep breath. Say goodbye to the Milky Way. Now this is many million years away from now. But this is mathematically what we believe is going to happen. You'll get what's likely called a ring galaxy. It's going to be a spiral that has the middle pulled out of it. Just incredible. Sometimes you gotta know when to just keep your mouth shut and let the simulation roll. The cores, or the supermassive black holes at the center of each of these spiral galaxies, will then have this beautiful dance. You see them kind of fighting around here in the middle. We're going to be talking more about the Milky Way and some of the older stars and older clusters. We talked about open star clusters during our show. There's actually a thing called a globular cluster. You primarily see them during the summer months, and that's why we didn't really talk about them. They exist around the core of the Milky Way, and the core of the Milky Way is visible during the spring and the summer, and that's why we're waiting for it. So if you haven't already done so, please make sure to like and subscribe and ring the bell on whichever platform you like, whether it's Twitch, whether it's YouTube, or if it's Facebook, whatever you're using. Follow along, ask questions. I'm more than happy to answer them throughout the show. Plus, I do make offline video content and then upload them as needed to supplement. Oh god, that's really bright. To supplement what we talk about. It is a two-person job that we have here. It's just myself, my wife, and our cat and dog that we're doing everything ourselves. So sometimes our turnaround time is a little bit slow, and we are trying to improve on that, but we are doing the best we can. As I said, Andromeda is out tonight. Andromeda will be leaving our sky in just a few weeks. If you want to get a chance, or at least go out and look at her, you don't need a telescope to even see the Andromeda galaxy if you live in a good dark sky. But if you don't, here's how you find her. Remember Cassiopeia? We talked about her earlier. Well, instead of using the open-ended side of this triangle, let's use the tip. Just the tip. Draw a line through the tip of this triangle, and you will end up very close to a star. That star is part of Andromeda, which looks like an A in the sky, an upside-down A. She's the chained maiden, chained up in the sky. Just off of her waistline is the Andromeda galaxy, and you'll see that that A goes like this, it comes and points this way. Or, again, you find Cassiopeia, make your triangle. 1, 2, 3, triangle points, and you'll see a little fuzzball. For a very long time, this was called the Andromeda Nebula, until telescopes got better and until cameras got better and people started taking long exposures and layering them. It wasn't discovered, it was discovered that these things actually not a blob in the sky, but a spiral arm, and more spiral arms. It's a spiral galaxy. Now, remember I said there's football-shaped galaxies? There's actually a companion galaxy near Andromeda. That's right down there. That is an elliptical galaxy. Very, very cool. There's lots of galaxies in the sky. I didn't even talk about all of them. I can't talk about all of them. There are many, many, many that you can see. There is one right near the tail of the Big Dipper, which is one of my favorite ones to point out. This is called the Whirlpool Galaxy. That's a fuzzy picture. That's terrible. Terrible, terrible news. Jack's been blown to smithereens. Let's look at the Whirlpool Galaxy from Astronomy Picture of the Day, shall we? Maybe. Okay, you don't want to do that? That's okay. Browser freaked out. That was weird. Let's get out of this. Let's get out of this. Let's go to our... There we go. Much better. Look! Behold! High quality image of the same thing. This is the Whirlpool Galaxy. I can't even fit it in the screen. There we go. This is the Whirlpool Galaxy. Now, I need you to understand this is a three-dimensional image. You just can't see it that way because we're looking at it on a flat plane. This galaxy is in the front. This spiral arm up here is reaching behind. So imagine, like, if you're sitting down, if you have the ability to do so, reach behind you with, I don't know, your left arm, if you have the ability to do so. That's what this spiral arm right here is doing. It's reaching back to grab this other galaxy. This material is being pulled off towards this elliptical galaxy. Remember we talked about Orion and the star-forming regions, all that hydrogen alpha? That's what's labeled in red here. These are all areas where stars are being born in this galaxy. And we see the same thing. Blue stars, younger, hotter stars on the outer edges of the galaxy. Older, redder colored stars towards the middle of the galaxy. Like, this is phenomenal. And it's out tonight. I didn't even talk about it. Why? Because I'm a dummy. Also, because you need a telescope to see it. We're trying to do just visual astronomy. But there is one other thing I want to talk about before we end. We only got a couple minutes left. Answering a question here. Apologies for that. There's a thing that we call the Hubble Deep Field. Now imagine holding a pin, P-I-N, a pin, not a pen, just a pin, at arm's length. That's about what the Hubble did. It looked at a small, inconspicuous portion of the sky. A part that people thought was just empty. And they left the camera open for months and months and months and months. And what we ended up with was this. There's the Hubble Deep Field, and this is the Hubble Ultra Deep Field. Now, remember what we learned earlier. When you look at certain things like this, you want to look for bright, spiky things, like this right here. That is a star. That is a star in the Milky Way. That is a star in our galaxy. It just happens to be in the way. And we see a couple. Nope, go God. There's one down there. There's one down. Come, zoom in. Please zoom in. There's one down here. There's one here. Those are stars. Okay. That's a star. That's a star. There's a star up here to the top right. You see it up there where my mouse is? That's a star. Everything else you see here is a galaxy. Everything except for the little spiky point. One there, one there, one there. I pointed out as many stars as I could. Everything else is a galaxy made of millions, billions of stars. Potentially trillions of planets. You'll notice some have spiraling shapes already. There's one right here. That's a barred spiral, it looks like. There's a spiral there. There's kind of a spiral there. Got an elliptical. There's a definitely... Ooh, look at that spiral. You're zooming in the wrong way. There it is. Look at that spiral. It's like the Eye of Ra. And you see these little dots in the distance? Those are galaxies too. They're just not resolved in this image. There's an elliptical galaxy. There's an elliptical here, elliptical there. All of these little dots in the distance, those are galaxies. When you study astronomy, particularly when you study galactic astronomy or what we call cosmology, you start to look at very distant objects. You start to think of the age of the universe. Where did it all come from? What is the Big Bang with the supposed explosion that started all of this in motion? Do we have eventually what is called the... is everything going to recoalesce and like snap back? Right now, everything's expanding away from us from our point of view, except for Andromeda. When you look at something like this, you are looking back in time. Light takes time to travel through space. This is how you become a time traveler to these distant galaxies and the distant worlds that are within them. All of which you are still somehow connected to because you are stardust. And these are all eventually going to be stardust, or they may already be stardust. They're just so far away we don't see it yet. When you stare at the nighttime sky, you look back in time. The one thing I always tell people to do is to look at the sky. Get a little star book. There's lots of different astronomy books. I always recommend, I'm not affiliated with them, but I always recommend the Audubon Society Field Guide to the Night Sky. Lots of cool stories, lots of helpful maps. Fits in the back pocket, so you can take it in your backpack or in your pocket as you go for a hike or whatever. But it has charts on the distances to certain stars. A lot of the bright stars we can, measure their distances through various means. We're going to use a star. I'm going to pick a random star. Don't know what it is. It's in Monoceros. That's fine. It says 147 light years away. That's not a good example. This one's 79 light years away. Okay, this is Regulus. Regulus is in Leo the Lion. This has a listed distance of 79 light years. Now, if you have a grandfather or grandmother, or maybe your parents are older, this might work for them. Find someone that is 79 years old, turning 79 this year. This is the example we're going to use. Let's say we have a grandparent. I just lost my grandmother, so maybe that's how this all ended up, but she was 97 years old. So I would have to find a star 97 light years away. But let's imagine she was turning 79 this year, so that's the inverse. If I put a telescope in front of her and she looked through it and she looked at this star, and let's say today was her birthday. It's not. Let's say today's her birthday, and she's turning 79 today, and she looks at this star through a telescope. The light that she sees in the telescope is the light that left that star the day she was born. It took all her life for that light to get here tonight, for her to see it. And that's the way it works with all of these objects. They're all different distances away. These shapes that we see, it's just from our point of view here on the Earth. Go to Mars and it looks slightly differently. Go to a different star and look around and everything will look completely differently. You'll have different constellations. The constellations that we do know will be stretched out or in very, very contorted areas. Distorted shapes. So this is all very special to us here as Earthlings living on this planet. Again, our show changes on a weekly basis. We do go over some similar things because, of course, every week things don't change all that much. But if you've been joining us for the last few weeks, you know we're not talking about certain things anymore. And we will be talking about some springtime and summertime things as we go along. You see the Milky Way is this trail right along here. During the winter months, we look towards the outer edge of the Milky Way, so it's easier to see deep sky stuff, galaxies, things like that, open star clusters. During the summer months, we look towards the heart of the galaxy, and so we see a lot of the things that are near the inner portion. So the next few weeks, we'll start talking about springtime stuff and talking about the eventual coming of the summer months, which will have the heart of our galaxy. Working on getting a telescope fixed up so that we can use it to take some pictures of our own and maybe even do a live stream where we can see through the telescope all together. That could be a pretty cool thing. We're hoping to get that all together, and again, that's kind of what we're hoping to grow the channel, get more people watching. I don't just do this for myself. I do this for my family and for my friends and for all of you out there that maybe I don't know yet. Because astronomy's for everybody, and I just want to help bridge the gap. Maybe you never learned about astronomy, maybe you learned about it but forgot, maybe you're obsessed with it, and what I'm saying doesn't satisfy you. Well, then comment and try to coax more out of me. I try to keep things as semi-basic as possible. I don't want to go too in-depth in certain things. I don't want to lose people, because I don't know where everybody's at. If I'm in a classroom, I know the grade or the level that most everybody's at because I have my students, and that's the way it goes. This is the internet. Anybody can click, anybody can watch. I don't know where you're at, so I'm going to try to give a good basic educational thing to everybody. Maybe it'll make you go read more books or go watch other videos from other readers, other viewers, I should say, other creators. Tell them that you found them because of me. Maybe they'll come back to me, so we can all grow together. But yeah, that's our show. We just did 2 hours of astronomy. I appreciate those of you that commented or asked questions. That is always super helpful. Please be on the lookout for videos. There actually is a video that's supposed to explain the month of March that should have been up, but then, like I said, we had a family tragedy, so that kind of didn't get put up. I will get that up post-haste. I do apologize for that. And we'll try to be back on Wednesday. Editing does take a good long while. We've got a couple of videos coming up soon. Again, the Astronomy 101 series is finally launching. I've been wanting to do this for a long time, and I finally figured out how I want to do it and what we're going to do. So please look forward to that. With that, I bid you all adieu. Have a wonderful afternoon, evening, morning, wherever you happen to be on this beautiful planet that we call Earth. Take care of yourselves. Take care of each other. May you have clear skies. Breathe deeply. Enjoy life as best you can. We'll see you next time.